Hello, my name is Matt, and in this video I'm going to be teaching you how to use the stud transform function in the C++ standard to modify vectors, arrays, or any container that you may have in your code in C++. Before we start, I would like to ask you to please have a look at my website and check out the posts that I've got there. I've got many software development related posts, including a lot of C++ and CMake videos, which you may find useful. So let's get into it very quickly. So in here, I've got some code that I actually had in my previous video, the stud find if video that I've made. Essentially, I had a class, a struct here called person, and that held a certain member such as weight, age, and the name of the person. And for this video, I've added a member called weight, which is the weight in kilograms of a person. And this is just so we can do a particular exercise in this video, and you'll see that in a bit. And I've also got this static constexpr array, and that has 8 elements in it, and each element is of type person, and each element basically represents a person that I've made up essentially. So you can see here the first element is my name here, age of 24, weight of 60 kilos, which is not what I actually weigh, I wish I did, and my height 1.7. Before we actually start the main exercise in this video, let's take a look at the documentation for stud transform and why it's useful. So stud transform, and I'm here on the CPP reference, is basically very useful for when you have a vector, an array, a map, or any sort of C++ container, and you want to basically transform or modify each element into something else and store those results in a different container. And this is what transform is for. It literally transforms your vector into something else. And, is actually a good name in this particular case. So there are many calling conventions, as you can see here. And the particular one that we're going to use in the first place is this first one here. So the first sort of variation of stud transform takes in 2 import iterators, as you can see here, import iterator 1 and then the first and the last. And this is basically the elements that you want stud transform to go through. So it'll go through your first element up until the last one, but not including the last one. And then it also takes an output iterator. And this output iterator is essentially the destination places of where your modifications will be going into. So whenever, for example, it will go through the first element, you will modify that, and then that will get added to the first, output iterator here, and then the second one will get added after that, and so on. And then the last argument that we've got here is this unary operation here, which, name may be a bit misleading or complex, but essentially it just means a function, a pointer, or a functor, or a lambda, that will be called on every element of your range that you passed here, from the first to the last element. So transform is going to take this function here and pass in each element to it and save the result of that function of this lambda, let's say, because we're going to be using lambdas here, and it's going to be saving it onto the output iterators. That's all it's going to do. Essentially, is just a glorified for loop with better readability. So let's get into it then. So the reason why I added this weight variable here is just so that we can get the BMI for every person in my sort of people array here. So basically, we're going to be taking every element of this array and we're going to transform into the equivalent BMI for each person. So we can do something like this. We could create another struct called person BMI. And in here, we can hold the actual BMI in a floating point. And then let's say we want to also store the name of every person. So the intent here is to transform each of these elements into each of these person elements into a person BMI. And I think I missed a semicolon, which is actually one of my most common errors. And there we go. So let's do that with transform, and then I'll actually explain how it works afterwards, after I finish the code. And this is it. This is very quickly how you can implement something like this with std transform. So what we did here is we began calling std transform. Actually, before even that, we created a vector to hold our results. The std vector of person BMI here called BMIs. And you can see that I added the vector header here. And then we called the stud transform function. And again, that comes from the algorithm header that I added at the very top. And with that, I passed the begin of people, saying, we should start from the beginning of this list. So whatever is at the start, that's what we're going to do. And then for the last import iterator, we passed the end of the list, which actually, if you know C++, is the element after the very last one in your list. So as I said, transform is going to go for from the first element up until the last one, but not including the last one. So essentially, it's going to go through all of this because end of people here would actually give me the element after the last one. So it goes through all of them, and that's how you can use it here. Okay, and just bear in mind that this is actually the same as doing stud begin. It works in the same way because of something called ADL in C++. You can look up that if you want, but it's just a neater way of writing that. So begin of people, end of people, and then a very important note is the actual output iterator that I'm passing here. You can see that I typed back inserter of BMIs. And what this does is, if you're using a vector or any elements that you can insert at the back in C++, calling stud back inserter, so like this, stud back inserter, or simply back inserter with ADL, simply means that C++ internally is going to create you an output iterator where every element that's going to be added for each iterator is going to be at the end of that container that you've got. So in that case, BMI starts as empty. So in the first instance here, it's going to go for the first element of people, and the result here that we're going to get from transform, and I'll explain that in a bit, is going to go onto the back of BMIs, which is the first element, and the second one will go to the back, so after the first element, and so on and so forth, right? And then the very last, as you can see here, the very last argument to transform, which is this bit of code, is my lambda, and this lambda has to have a particular format. So either if it's a lambda or if it's a function pointer or a functor, it has to take in exactly what I say here. So the lambda or the function pointer has to take the same input type, one input type, as the input iterators, as what the input iterators refer to. In my case, it's a person type, right? But because I'm using autoconst here, and I actually recommend writing autoconst unless you've got a very sort of primitive type, writing autoconst reference is basically going to avoid you from having to sort of refactor this bit of code in case the type of people changes in the future. So autoconst is perfectly fine here. It works in most cases very well. So I'd recommend that. So that is the argument that this lambda has to take, and the return type of that lambda has to be the same type as what the output iterator refers to. So in our case, output iterators here are referring to the person BMI. So this lambda here has to return a person BMI because that is the type that's being added to our vector, as you can see here, our destination vector. It has to be that type, otherwise you're going to have compilation errors, right? So this is what it's doing. It's transform is going for every element of people, running this particular lambda here on every single one of them. And with the return types, it's actually inserting at the back of my containers here. And that's exactly what it is. And it's very simple to use. And I'd recommend you trying it out because it's a function that comes up quite a lot in many different problems. So whenever you've got a vector that you want to change into something else, you're probably going to be using transform here. You could, of course, write this as a for loop, either a raw for loop or a range for loop. Both will do the same thing, but transform will keep your code, in my opinion, a little bit more readable, because as soon as I look into it, I know exactly what you're doing. You're transforming the elements of people and inserting it into this destination array here, and that conversion function, if you call it, is going to be whatever your lambda is doing. So it's very easy to do, and there are many sort of different ways you can call transform. Specifically, there's this third way here, which instead of taking two input iterators, it takes three. So it takes the first and the last element for a list, and then it takes another one here, input iterator 2, first 2. And it doesn't actually explain it very well here, maybe on the documentation here. I haven't actually read it. But what this does is, instead of just focusing on one array to convert types from, you can have two different arrays in the transform. So you can transform two different arrays into one single array. You can combine, let's say, two different arrays into one result. And this is actually very useful for example, if you're writing something like a zip function in C++. So for the Python programmers that are watching this, you probably know about the zip function. And in Python, that function takes in two lists. What it does essentially is it combines each element of those two lists and returns you a list with pairs, where each element is a pair of the element in the first list and the equivalent element in the second list. So let's write that in C++ so we can, basically get an example of how to use this order calling convention. So this would be a very sort of naive and probably very inefficient implementation of the zip function in C++. So what I did is I included the utility header. I think the pair struct comes from that, so I'm not entirely sure here though. And I've defined this function called zip, and the return type is a vector that is a vector of pairs, and you can see here of type T and U. And these are, it can be any types because they're templates. And if you don't know what templates are, I would recommend looking up in C++. They're very useful in certain cases, such as this one here, if you're writing generic functions. And the input types of this function are essentially two different arrays of two different types. And what we do here in the function is we create that results array that we pretty much have to create when using a std transform. And that type is the same type as the return type here. So a vector of pairs of T and U. So each element is essentially a pair where the first element is of type T and the second element is of type U. And then we call immediately a transform here, and you can see that I'm passing begin of A, end of A, and also the begin of B here. You note that it doesn't take the end of B because it doesn't need to know where the end of B is. The only assumption here is that B is at least as long as A, so when it's looking at each element of both of them, you're not going to run out of elements in B if the elements in A are longer, if it makes sense. So I'll let you figure out what happens, if that is the case, if B is actually smaller than A, and you're probably going to run into some errors, some runtime errors there, but you can figure that out yourself. That's the homework. And the back inserter here of results, so I'm saying that whatever results we're going to have is going to be inserted at the back of the results array, or vector in this case. And the lambda is a little bit different here in this case as well, because instead of having one input to the lambda every time, it's going to have two. It's going to have an input from A and an input from B. And the same constraints here are the same thing. So the very first argument has to match the type of A, and the second argument has to match the type of the vector B here. Okay, so that's the only constraint. And the return type has to be the same as the types in results. In our case, we're simply just returning a pair of constructed from each element A and B, and that is it. That's what we return from the function, and this is essentially what this zip function will do. So let's just to make it clear, we're doing something like this. So this is what our zip function here does. It takes in every element of A and basically zips with the element of B and returns that as a list of pairs. Okay, so let's call that and see if we can actually make it run. So zip. Let's call it with, say, BMIs and people. Oh, people is not going to work, I guess. And there you go. After wrestling with the compiler here, I figured out that there was a mistake in the template deduction here, but all I had to do is just remove the explicit types and you would work out the right type. Anyway, so this is what we can do. We can call zip with BMIs and people vector and display those values. So and there you go. So this code here, I've shifted it up a little bit, essentially shows that the zip function does work indeed. So I'm basically outputting the BMI for each person and the height of each person, which is only available in the other array. So yeah, it seems to work, and this is how you can use std transform. And that's it. I mean, if you enjoyed the video, please give a like and subscribe on the channel and check out the website. Please do post any questions or suggestions under the video and I'll get back to you as soon as possible. And that's it. Thank you and bye-bye.